Hello students, this is Coach Holliday, and today we're going to look at the last three rules in simplifying problems with exponents in them. So if you'll take out your notes and let's go ahead and get started. All right, the first one we're going to look at is the negative exponent rule, okay? And this one is the one that may be a little bit the most confusing one to you, but we're going to work through it and see how we do, okay? So let's start off like we did the others, and let's go ahead and expand and simplify some expressions, okay? The first thing I want to do is I want to remember real quick our rule when we had division with the same base. If you remember, we kept the base and then we subtracted the exponent. So we had 3 minus 5, which made negative 2. So x to the third over x to the fifth is equal to x to the negative 2. So there's a problem or an expression that we have a negative exponent, okay? But now I want to go back to the expanding part. I want to expand this right here, okay? So let's do this. X to the third is x times x times x. X to the fifth is 5x's multiplied together. And then let's do what we did yesterday, and we'll cancel out. Okay, so I'll cancel 1 on top, 1 on bottom, 1 on top, 1 on bottom, 1 on top, and 1 on bottom. And now let's rewrite this, okay? So if I look, I have on the top there's nothing left, so I could always multiply everything times 1. So on the top we just have a 1 left. On the bottom there's 2 x's, which would be x to the second. Alright? So if you'll notice, if I use my rule from yesterday, this is x to the negative 2. If I expand it and then simplify, it's 1 over x to the second. All right, let's try this for the next problem. All right, x to the second over a to the second over a to the third. So let's use our rule, and we'll have a as our base, and I'll subtract the exponents, top minus bottom. So 2 minus 3 is negative 1. So here I have another negative exponent. All right, so let's go ahead and do this by expanding again. And when I expand, I have 2 a's on the top, so a times a, and I have 3 a's on the bottom, a times a times a. And let's go ahead and cancel. An a there, an a there, an a there, there, and I'm left with, on the top there's nothing left there, so I'm just going to put a 1 to hold the place. In the bottom I have an a. Or I could say a to the first if I want to, okay? So if we wrote this out using the rules from yesterday, we get a to the negative 1. When I expanded then simplified, I got 1 over a to the first, okay? All right, last practice one here, or last one before we write the rule down. Let's write what this one is, okay? So if I use my rule, remember that's m to the first. If I use my rule, I have m as my base, and I got 1 minus 4, which is negative 3. All right, so now let's expand it. And I have 1 m on top, and I have 4 m's on the bottom. And let's go ahead and do our canceling. I have an m on the top, an m on the bottom, and that's it. So what do I have left? On the top there's nothing left, so I'm just going to put a 1 there to hold our place. The bottom is I got 3 m's, so that's m to the third. So using my property from yesterday, I get m to the negative third, and using my expanding and simplifying, I get 1 over m to the third. So if I look at this and look at what I did, this, the x to the negative 2 and 1 over x to the second have got to be the same thing. A to the negative 1 and 1 over a to the 1 are the same thing. And m to the negative 3 and 1 over m to the 3 are the same thing. So what this does, it leads me to my rule. If I notice, all I did was I took the top part up here and I moved it into the bottom of my fraction and changed it to a positive exponent. And that's basically what the rule is. So for any number x, x to the negative a equals 1 over x to the a power. And also, if I use the reverse of that, if I have a negative on the bottom, I flip it and move it to the top, just like I moved this. I made a fraction to the bottom. I just flip it over that fraction bar. So I just get x to the a over 1, or just x to the a there. Okay? So if the exponent is negative, What do I do with it? I flip it over the fraction bar and make the exponent positive. Okay, and that's our rule. So let's look at these in application. All right, so the first example, 2 to the negative third. So remember, if I make it 2 to the negative third into a fraction, it'd be like over 1. So what I do is I take this and I flip it down to the other side of the fraction bar, and I make the exponent positive. And then on the top is just left a 1 there. For the second one, notice I have some things with negative exponents and some things with positive exponents. So first thing is, let's put our fraction bar, the 4 to the negative third, that's negative, so it's got to flip and go to the bottom and make it 4 to the positive third. The x has a positive exponent, so I leave it on top. And notice this y to the negative 2, it's on bottom, it's got a negative exponent, so I have to flip it over and put it up on top with the positive exponent. And there is our simplified version. Okay? All right, let's move on to the second rule. That was the negative exponent rule. Let's look at the second exponent rule for today. And that's raising a product to a power. So raising a product to a power. So what that means is I've got in this parentheses a product, which means two things multiplied together. I got a product, a couple things multiplied together. I got a product, I got three things multiplied together there. So let's raise it to a power. So let's expand and simplify this and see what rule we can come up. So if I have a parenthesis squared, that means I'm going to multiply the parenthesis times itself twice. What's in the parenthesis? X times y. So all this just means multiplication. So how many x's do I have? I have 2 x's, so it's x squared. How many y's do I have? 2 y's, so y squared. All right, let's do this with this next one. I have 5 of these parentheses, so 3a squared is times a times a. And I got to do this 5 times. One more time. All right, and let's simplify this. I have my 3 there. How many 3's do I have? 1, 2, 3, 4, 5. And how many a's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so if you look back at the first example that we had here, the first one, it looks like the exponent for both parts inside ended up being a 2. So looks like I just distributed that 2 in there. For the second one, the exponent for the 3 is a 5, so it looks like I distributed that to there. And also to there, because remember I have a power to a power, I multiply. 2 times 5 is 10. So let's see if that holds up on this last one over here. And so I have 4 of these parentheses. So I have 5x, y, y, 5x, y, y, 5x, y, y, and 5x, y, y. So how many 5's do I have? 4, so I'm going to raise that to the 4th. How many x's do I have? 1, 2, 3, 4 of those. Raise that to the 4th. So if you look, it looks like I just distributed that 4 to the 5 and the x. And now if I distribute it to that 2, I have 1, 2, 3, 4, 5, 6, 7, 8. So y to the 8th. And remember, 2 to the 4th power is going to, y squared to the 4th power is going to be y to the 8th. So what happened when I did this? When I raised up a product to a power, I just distributed the exponent. That's all I'm going to do. So the rule would be, if I take this n and I distribute it in, I'm going to have a to the n and b to the n. And remember, I'm just going to follow all my other rules. Okay, so let's try this. An example. I have this product 4 times a squared times b, and I have that whole thing raised to the 3rd power. So I'm going to distribute it to each part here. So I have 4 to the 3rd. I have a squared to the third, and I have b to the third. Let's simplify that down now. So 4 to the third. A squared raised to the third, remember I'll multiply the exponent, so that'll be a to the sixth, and then my b to the third. And that's the simplified version of the product to a power. Okay, we have one more property we're going to look at, and that is the raising a quotient to a power. Raising a quotient to a power. Remember, a quotient is just a fraction, okay? It's just a division problem. All right, so we're going to look at that the same way we just looked at this last problem with raising a product to a power. So let's look at the first example, or the first one we have here. I have 3 of these parentheses, so I have m squared over n to the 5th once, m squared over n to the 5th again, and m squared over n to the 5th a third time. All right, now if you remember from fractions, we multiply across the top and we multiply across the bottom. Okay, remember our rule, so I have 2 m's, 2 more m's, 2 more m's, so that's m to the 6, 2 plus 2 is 6, and I have n to the 5, 10, 15 on the bottom. Okay, so how do I come up with m to the 6 from n to the second to the third? Well, I just multiply the 2 times the 3, and I also multiply the 2 times the 5 to get the 15 there. Okay, let's do the next one. I have 2 of these parentheses, so I have b to the third over d to the fourth, and I have 2 of those. All right, so when I multiply those together, b to the third times b to the third is b to the 6th, because I add the exponents. D to the fourth times d to the fourth is d to the 8th, because I add the exponents. If you'll notice, I just took that 2 and distributed it. 2 times 3 is 6, 2 times 4 is 8. So let's look at this last one. Remember, if it's x without an exponent, I'll put a 1 there. All right, and I'll expand. I have 4 of these parentheses, so x over y to the 6th, x over y to the 6th, x over y to the 6th, and x over y to the 6th. Put it back together, I have 4 x's on the top, so it's x to the 4th. On the bottom I have 6, 12, 18, 24. So how did I get 4 on the top? Well, I did 4 times 1. How did I get 24 on the bottom? 4 times 6. All right. So in raising a quotient to a power, again, we're going to distribute the exponent into the top and the bottom. So I'm going to take this n and multiply it is the exponent at the top and exponent at the bottom. So this is going to give me a to the n over b to the n. All right. So let's use this rule to simplify these two examples. All right. So I'm going to take this 3, I'm going to distribute it into the x and to the y. So that gives me x to the third and y to the third. And that's the simplified version there. For this one, I'm going to distribute it in to the top and to the bottom. Now notice the top is a product, so I'm going to put parentheses around that. I'm going to make this 5m to the third raised to the fourth over n to the fourth. And then remember we're going to distribute this top one in there. So I've got 5 to the fourth, m to the third raised to the fourth. I'm going to multiply 3 times 4 is 12. And on the bottom I still have my n to the fourth. And there is the simplified version here. All right, and that's it for the properties. That's the 5th, 6th, and 7th properties in the laws of exponents. We'll work on some problems of this in class tomorrow.